Viewers, welcome to our lesson on revision mathematics, a set which we have prepared to help you go through the revision for the topics that we have already covered in Form 2. I am your online teacher, Mr. Steve Getau, and I do welcome you to this lesson. In this lesson, we shall cover topics in evaluating using logarithms. Students call this the logarithm part, or the work in logarithms. We shall look at reciprocals in questions 4 to 5. In number 1, we shall have 1 to 3 logarithms. Question 4 to 5, reciprocals. In part C, we shall have indices. Questions learning from 6 to 9, and then we shall have a set of activities in number 10 to 11. So kindly join me, and this is a recorded lesson as part of the series of lessons we have been having on remote learning. Once more, welcome, and allow me to say that this lesson is suitable for learners in Form 3 who have covered this lesson, for Form 4 who have already also covered this lesson, and best for the Form 2s who are currently covering this lesson. Please get yourself a calculator, mathematical table, and let us get rolling. Number 1, we shall look at part C. In part A. Part A is on logarithms, and I want to highlight the objectives of every part. That in A, at the end of the lesson, the learners should be able to state and use the various rows of logarithms. In part B, the learners should be able to evaluate and calculate the reciprocal of any particular number given. And in part C, learners should be able to use the rows of logarithms of indices. I beg your pardon. The rows of indices in calculating or in evaluating some given equations. This will best be shown when we come to the activities. Activities will be questions that I will let learners work on your own, and then we shall have responses at the end of this lesson. You can write the responses on the charts, on the comment section, and you can also let me have the answers. In part 1, the logarithm part requires that we need to look at the various rows of indices. So we have rows of logarithms, rows of logarithms. We have 3 of them. The first one, Roman 1, we call it the multiplication row, whereby if numbers are multiplying one another, A multiplied by B, the logarithm of that will be the log of A added to the log of B. Then in part 2, we have the logarithm arising from two numbers dividing, A divided by B. What is the logarithm to that? It is the log of A subtract the log of B. We also have a third law, which is drawn from when a number is raised to power n, a given power, a given index, and that becomes n log A. The index or the power becomes a multiplier here. So this is going to be very useful as we work out the questions that we have. Let's move on to question number 1. Question number 1. In our question number 1, question 1, we are told to evaluate using logarithms. Evaluate using logarithms this number, or this set of numbers, 415.2 multiplied by 0.761 all over 135. 135 or over 135. So straight away, let's look at the solution to this question. Let's look at a solution to this question. We are going to use the number and logarithm format, whereby we have the numbers here. Then we shall have that number in standard form and the logarithm at that end. So we can tabulate our answer in this form. Whereby here we have our number. This is the number in standard form, and here is the logarithm of that particular number. Our first number is 415.2. In standard form, it is 4.152 times 10. We look at how many steps have the decimal point moved. It has moved 1, 2. In reducing to 4, the 415, we reduce it to 4.15, then we expand it back, we give it back its value by multiplying by 100. So learners, I would like you to go to your logarithm table, the mathematical table, and we read the logarithm to 4.15. So on the first column, we have 4.15. I'm reading 6180. So how do we read on that one? We go to the x column. And we trace 4.1 and then 5 in the middle column. And then on the last column, we check on 2. The 2 has a 2 also. So to 6180, we add 2. So that gives us the characteristic here is 2.6182. Let's come to the second number, 0.761. This comes to be 7.61 times 10 to the power negative 1. And this is, the characteristic here is bar 1 point. So I would like our learners check on the logarithm of 7.61. And there I have 8814. 8814. So if we now use the laws of logarithm that we highlighted in number 1, when the numbers are multiplying and you need their logarithm, you add their two logarithms. So here we are going to add. Upon adding, we get 2 plus 4 is 6, 8 plus 1 is 9, 1 plus 8 is 9, 6 plus 8 is 14, we carry 1, 1 plus 2 is 3, 3 plus bar 1. That's equivalent to 3 plus negative 1, and we get this as 2. So we get 2.4996. Okay, let's confirm that. This is 7.61. So characteristic here is a 1, and that is correct. Now, let us go on with the denominator. This gives us the numerator. In the denominator, we have 135. So, this number in standard form gives us 1.35 times 10 to power. The decimal point is here, so 1, 2, power 2. And that gives us 2 points. So, let's read the logarithm of 1.35. I'm getting 1303. 1303. This part of the logarithm is called the mantissa. This part is called the characteristic. Now, once more, we look at this case. When two numbers are dividing, what do we do to their logarithms? We subtract. So we are going to subtract the logarithm of the numerator we subtract the logarithm of the numerator minus the logarithm of the denominator, what do we get? 6 minus 3 is 3. 9 minus 0 is 9. 9 minus 3 is a 6. 4 minus 3 is a 3. And 2 minus 2 gives us a 0. 0.693. So at this point, we are directly going to look for the antilog. The antilog to this can be read from the logarithm table. So we turn to the section on antilogarithms. In my table, it is page 3. And I check 0.36. So 0.36. I have 0.36. And that is 0.36. I check on 9. At that point, I have 2.339. So 2.339. I'm left with the last digit. So 0.369 on column 43 up here. I come down and I check on the intersection for 0.369. I have a 2. So I'm going to add 2 to the last digit, and I'm going to get 2. I start with this one. 9 plus 2 is 1. Carry 1 to get 4, 3. So I have the number 2.341, and this number is already in standard form, so power 0, and that comes to be 2.341. So basically, we have learned how to read and also utilize the various logarithms that we have obtained. As we move on to question number 2, I would like us to take it as an activity, and then we are able to move on, and that will give us a good practice. In fact, question number 2 will be an exercise. Welcome back. In our question number 2, we look at a similar question which says evaluate using logarithms 24.36 times 0.06654, all right, divided by 1.48 square. The result of that, we cube root. We get the cube root of that number. So how do we go about it? Quite simple. We put this table on number. Number is standard form in the respective logarithms. Straight away, let's put the numbers. We have the first number, 24.36, and in standard form, this is 2.436 times 10 to the power 1. So the logarithm is 1 point. So viewers, get your calculators, get your mathematical table. For those who are going to use a calculator, remember we put the answer to 4 decimal places. So what do we get? We get 3867, 1.3867. In part 2, we have that number 0.06654. I chose this number deliberately to help us see how do we work out the standard form and the respective logarithm. So that gives us 6.654 times 10 to the power what? We move this decimal point 1, 2 times 10 to the power negative 2. And that gives you by 2 points, 8231. 8231. Once more, we are multiplying the numbers, we add their logarithms. And that gives us the addition there. This is going to be 8, 9, 8 plus 2 is 10, carry 1. This is 4. 4 plus 8 is 12. 20.98. Then we've carried 1, which we add here. Positive 2 plus bar 2 is a 0. It's equivalent to 2 plus negative 2. Let's come to the that's the denominator. We have, this is numerator part. Denominator, we have 1.48 squared. So we shall leave this as 1.48. times 10 to power 0, then we square that. So the characteristic is a 0 point. Then we read the logarithm of 1.48. So once more, get our calculator, get our tables. The log of 1.48, I'm getting 0.71703, which according to row number 3, we said we multiply by the characteristic. So this becomes times 2, and that comes to be 0.3406. So this is going to be our denominator. Now, these two values, numerator and denominator, should be subtracted because we are dividing the two. So once more, 8 minus 6 gives us what? We get a 2, 9 minus 0 is a 9, 10 minus 4 is a 6, then we have 1. We borrow 1 from 0, that makes 11. 11 minus 3 comes to be an 8. So we have 86, 92. Remember we had borrowed 1 from 0, so that gives us a bar 1. A bar 1, so we have bar 1 minus 0. Bar 1 minus 0 is a bar 1. Now this number, we are supposed to look at it as numerator divided by the denominator, the cube root of that. So how do we go about the cube root of this? We divide by 3. We divide by 3. And by dividing by 3, it is very important that we do the manipulation of the characteristic here. We can do it on a free space here, whereby we have bar 1.8692 divided by 3 being converted to, we subtract 2 from bar 1, we get bar 3. But we need to restore that value by adding 2. So I want viewers to see that bar 3 plus 2 is still bar 1. Then we say point, this part here, 8692 all over 3. I chose this question to enable learners overcome this challenge whereby there is the division of the characteristics by a given number, and that manipulation at times poses challenges to learners. So we divide 3 divided by bar 3, we get bar 1 plus 3 divided by 2 is not possible, so we get a 0 point. We shift the 2 to be 28. 28 divided by 3, we get 9 because of 27. Then you are left with 16. We are left with 1, making 16. That comes to be 5. We are left with 1. It comes to be 19. So 19 divided by 3 is 6. Then we are left with 1, 12. We get a 4. And that comes to be bar 1.9564. Bar 1.9564, whose antilog now we may read from the mathematical table as 9.0, 36, and on the last column we add an 8, and that gives you 9.044 times 10 to power negative 1. Negative 1 coming from the characteristic here, times 10 to power negative 1. And that gives you 0.9044. 0.9044. In this question, I would like us to look at the marking when the question is awarded 4 marks. How do we go about the marking for this? When all the logarithms are being read correctly, so the teachers will check, is your logarithm correct? The second one, and even the third one. If, especially so after the multiplication, if all the logarithms are correct, that earns you M1. The skill of knowing how to add and subtract gives you the second M1. The skill of dividing and getting the correct antilog gives you an M1. And then if your answer is accurate, then we get A1. and this student is able to score 4 out of 4 marks in that particular question. So this is a very good area whereby we are revising and seeing some of the areas learners get challenges. I would like you to know that read the logarithms correct so that the values you are working with are also correct. At times, I also advise students to check on their working by punching in this question on the calculator to verify during a practice session if they are doing the right thing. Right away, let's move on to question number 3. Question number 3. I would like us to have a practice question in number 3. Our practice question, you will work it out, and during the session on feedback, as you give me feedback, give me the answers that you got. So question number 3 is an activity question. An activity question. You work on your own and then you give me the feedback. The question says use logarithms to evaluate the square root of 3.361 times 0.054 all over, this square root is encompassing the 2, all over 24.5 minus 12.1. Viewers, as we look at this question, I would like you to identify the trick even before we begin on answering the question. There is a hidden trick that is there that you have to unravel before we work it out, and it's upon you. Tell me what is the trick in this question. That is our activity number 3, and now we shall shift to part B on reciprocals. Let's move to reciprocals. Welcome back. We look at question on part B, reciprocals of numbers. And the question is, evaluate using the reciprocal tables 1 over 0.342. So in this case, the main issue here is to note that the reciprocal numbers, as shown in the tables, are always in standard form. So we convert this to standard form and we get 1 all over 3.42 times 10 to power negative 1. 3.42 times 10 to power negative 1. We have made this number look larger or more greater, so we have to restore it by taking the decimal point one step backwards. Now, we would like to have only a single number here, so we eliminate the power 10, and by multiplying by 10 to power positive 1. Viewers, you will notice here that there is a rule which says 10 to power 1 times 10 to power negative 1 is the equivalent of 10 times 1 over 10, and that gives you a 1. 10 divided by 10 to get that 1. So what we are going to do is we introduce 10 to power 1 on both denominator and numerator. This portion here becomes 1, as we have seen there. So indeed we are talking about 1 all over 3.42 times now 10 to power 1. This portion here changed 1. When we multiply by 10 on both sides, we do not change the value of the number. So from the mathematical table now we read, it is important that we are able to read the reciprocal of that number. We get to our mathematical tables and we read on reciprocals. the reciprocal of numbers from my table is on page 17 of the next tables. I'll go to the column X, whereby I have 3.4. I check on 3.4 and then I read in the middle column 2. I'm getting 0.2924. So that is the value that I have, 0.2924. However, I need to put in this one times 10 to the power positive 1, and that gives me, that changes the decimal point forward 2.924. While we are at it, I would like us to look at a second part. What if the number is greater than 0, is not a decimal fraction? Like, what is the reciprocal of 342? That will be 1 all over, we change it to standard form, 3.42 times 10 to power, the decimal point is here, so we change it 1, 2. So we need to increase it by power 2. That way, we shall be able to have 3.42 equivalent to this one. Now, we remove this power here, this multiplication by 10, by having 10 to the power negative 2 on both the numerator and denominator, 10 to the power negative 2. And what does that give us? This gives us a 1, as we had seen up there. And so our number becomes 1 over 3.42 times 10 to the power 2. So we are going to read the reciprocal of this from the tables. And since we had read it earlier there, it is 0.2924 now times 10 to the power 2. Power 2 shifts the decimal point forward by how many steps? By 2 steps. 1, 2. And so that gives us 29.24. 29.24. We can go on and evaluate with this kind of a skill other areas, and I want to believe that the issue of reciprocals is not very, very challenging. I would like us to move on to part C. Part C on indices. Part C on indices. I want to believe that that part is very well done. Sorry, beg your pardon. This is an error. We have made an error here, whereby we should have put negative there, and negative there, and negative here, and this changes these two. 2924. We put the zeros, and we shift the decimal point from here 2 steps. So 1, 2, and that is the correct working. So we can now mark this one as having read or having computed this part very well. When a student is able to compute that, we are at A1 and A1, M1, A1. The computing of this part, the student should be able to arrive at this level, M1 and A1. In both cases, the learner is able to score the 2 marks. So that is good, and we have been able to correct that error that we had made earlier. So let's move on to part C. In part C, we are going to look at indices. The application of indices in advanced and in broader cases. Now, in indices, the rules of indices very similar to the rules of logarithm that we had said. One of them is that when the bases are the same and we are multiplying the numbers, we normally add the indices. The other one is when the bases are the same and we are dividing the two, we subtract the indices. So this is going to be very handy in our works. Let's go to question Number 5. Question number 5. We are told to solve for x in the expression 125 raised to power of x plus 1 added to 5 raised to power of 3x is equal to 630. Look at that question. 125 is raised to the power of this and added to 5 to the power of 3x, and that gives you 360. In this question, the idea of a common base is very important. So we look at 125 and 5. The factors 125, if you divide by 5, you get 25. Divide by 5, you get another 5 here. So 125 is simply 5 power 3. If we bring that concept here, we shall have 5 power 3, but it has a power x plus 1. Then we add 5 raised to the power 3x, which is equal to 630. So this part has the unknowns. Let us work them out until we are able to equate to this. So we open the brackets here to get the question better. 3x plus 3 added to 5 power 3x, and that is equal to 630. In that case, we are seeing the question at this level where the indices are added. What happened to the bases? The bases must have been multiplying. So we open up this as 5 raised to the power 3x multiply. Allow me to use the dot as a multiplication sign. 5 raised to the power 3. I'm using the dot so that we don't confuse at all with the x. So 5 raised to the power 3x multiplied by 5 raised to the power 3, then added to 5 raised to the power 3x, and that gives you 630. This expression can be shown as, you work this one back, as 125 multiplied by 5 raised to the power 3x added to 1 of these, so I can put a 1 here, of 5 raised to the power 3x. So there is only a single 5 power 3x being added to all these 125 of the 5 power 3x, and that is giving us 630. In a simpler way, we can visualize this as, I use a different color, as 125 of an A plus 1 of a given A. This should give us 126. That way, we are able to spot and see the results here. 125 of this plus 1 of this is 126 of the items called 5 to the power 3x, and that comes to be 630. So we can divide both sides by 126. By 126, when we get that, 5 raised to the power of 5 raised to the power 3x is therefore equal to 630. We divide by 126, we get it is equal to 5 raised to the power 1. When the bases are the same, then equivalently the indices or the powers are equal. This implies that 3x is equal to 1, and therefore x is equal to that. X is equal to that. So we have applied the rule of indices, and it is quite important. For a short question like this one, which is worth 3 marks, we need to look at which are the marking points. The marking points are, or will feature, when the learner is able to break down from 125 and 5 to a common base. So this gives the learners M1, the first method mark. When the learner is able to put the like terms together, that is the x's on one side, the known on the other side, at this level where we have 126 into 5 power 3x is equal to 360 M1, and the correct working here A1, and the learner is able to score 3 out of 3 marks. So this is a very good way of showing the application of the various rules of indices. Like in this case, we have applied the rule number 1. So with that, we are going to question number 6. Question number 6, and I'll also give you a practice question thereafter. Welcome back. In our question number 6, we have the question: evaluate for x in the equation 49 raised to the power of x plus 1 plus 7 raised to the power of 2x is equal to 350. So in this case, the trick here is to identify 49 as being having the 2, that is 7 to power 2. 49 can be expressed as 7 to power 2. Then we replace the power, x plus 1, add it here to 7 power 2x, and we can equate this to 350. We have taken 7 so that we may match with the power, the base 7 already used here. So opening up the bracket, this is now a continuation of what we had seen earlier. We have 7, 2x plus 2 added to 7 is power of 2x, and that is equal to 350. In this case, we open up, or rather we see that the powers are being added. What happened to the bases? The bases were multiplied. So 7 to the power 2x multiplied by 7 to the power 2 added to 7 to the power 2x is equal to 350. Now with that, we are able to see that this is equivalent to 49 of the items called 7 to the power 2x plus one item called 7 to the power 2x, and that comes to be 350. So 49 of this plus 1 of this, these are like, so this comes to be 50 items of 7 to the power 2x, and that comes to be 350. If we divide both sides by 50, divide both sides by 50, we get that 7 to the power 2x is equal to 7 power 1. Therefore, when the bases are the same, the indices or the powers are equal. 2x is equal to 1, and therefore x is equal to a half. Viewers, I think it is getting easier and easier every moment we discuss this one, and so I have decided that let us look at number 7, number 8, number 9 as an activity. So kindly put number 7 in your notebook, whereby we are saying, so for x in the equation, 9 to the power x plus 3, 2x minus 1 is equal to 53. The expected answer is 1.5. Question number 8, we have, so for x, 9 is to the power of x plus 1 plus 3, 2x plus 1 is equal to 36. The expected answer is a half. And in number 10, 81 is to the power of 2x multiplied by 27 is to the power of 2x divided by 9 to the power of x is equal to 729. The expected answer is x power 2 over 3. This is an activity that I would like you to do in the remaining 10 to 15 minutes of this hour, and we shall have your reactions in the chats, in the comments, and also in the live session. Put it down, and as we do so, allow me to make a conclusion here that this series of revision sets are enabling learners to revise and get ready for KCSE mathematics, be it paper 1 or paper 2. I have been I'm very happy for you joining me, and I continue awaiting your responses as we move on. Remember, we have more of these materials, revision materials, in a YouTube channel. You can search on the YouTube handle, that is, you search on the handle at Steve Gitau, that is 660, and you'll find a lot more of the videos in the playlist, and the playlist has put these materials in terms of classes and the subjects. Thank you so much, and I await your responses for these 3 questions in the live section. Thank you, and God bless you.